Now, we're going to look at some properties of the inverse functions, and these really come from them just being inverse functions. So remember, when we first learned about inverse functions in general, we said if you compose f composed with g or f composed with f inverse, you just get out x, and that's what we're saying here. So if you have sine composed with sine inverse, you just get out x for all x between -1 and 1. So if it was a value that you could plug in, because you can only plug in things between -1 and 1 to sine inverse, then you'll just get out that value. So for example here, number 3, we have sine of sine inverse of 1.4. Now 1.4 is bigger than 1, so we actually here have to say undefined, because you're not allowed to plug in values that are bigger than 1 to sine inverse. But look at number 2 here. We have sine of sine inverse of -0.34286. Well, since sine composed with sine inverse, and this is a value you're allowed to plug into sine inverse, these kind of cancel each other out, and you can say this is just -0.34286. Okay, let's look at the next one. So the next one says that cosine of cosine inverse of x is equal to x for all x between -1 and 1. So number 1 here, where we have cosine of cosine inverse of square root of 3 over 2, we can just say that's equal to square root of 3 over 2. Okay, and tangent actually works for all values between -infinity and infinity, since the domain for tangent inverse is -infinity to infinity. So whenever you see tangent and tangent inverse, they cancel each other out no matter what, and you can just say that's 75. Okay. Now, you can also do sine inverse composed with sine, and that's equal to x as long as x is between -pi/2 and pi/2. Okay, so here we have sine inverse of sine of pi/4, and pi/4 is in that domain, so we can just say that that's pi/4. Now what we have to be a little bit careful about is when it's not in that domain. So if we have sine inverse of sine of 3pi/4, 3pi/4 is not in there, so we have to work our way from the inside out. So we can't just say undefined, but we're going to say sine inverse, and then we're actually going to find what sine of 3pi/4 is. So we'll go to our unit circle and look up 3pi/4, and sine is square root of 2 over 2. So now we're trying to find sine inverse of square root of 2 over 2. And remember, that's the angle between -pi/2 and pi/2, where the y is square root of 2 over 2, and that's going to be pi/4. So our answer here is pi/4. So if the value is not in the restricted domain, then you actually have to work it out. You can't just kind of cancel those two. Okay, and the same is true for cosine. So cosine inverse of cosine of x cancels out if x is between 0 and pi. And tangent inverse and tangent of x cancel out if x is between -pi/2 and pi/2. Now we can actually compose these together, and this says find the exact value of sine of tangent inverse of 3/4. Now, what does tangent, remember, we're going to work our way up from the inside out. So what does tangent inverse of 3/4 mean? Well, so if we set that equal to theta, then we say tangent of theta equals 3/4. So let's draw a triangle about what that means. So if this is our theta, remember tangent is opposite over adjacent. So we're saying 3/4. Now, if we do the Pythagorean theorem, so if this is our hypotenuse or our c, 3 squared plus 4 squared equals c squared, we'd get 9 plus 16 equals c squared, so 25 equals c squared, so c is going to be equal to 5. So now what we're asking for is sine of that angle. We're saying what is sine of this theta? And sine here would be opposite over hypotenuse, so it would be 3/5. So the answer here is 3/5. So Sometimes, if it's not a value that's on the unit circle, you can use a right triangle to help you solve.